Hello and welcome. Ever wondered how scientists cook up those amazing new materials that could power your next phone, make cars lighter, or even revolutionize medicine? While the process is getting a massive upgrade, we're talking about automated digital laboratories, or dLabs. Imagine a super lab that runs 24/7, conducting thousands of experiments with perfect precision and actually learning from every single one. That's the core idea behind dLabs. These aren't your average science labs. They're advanced facilities integrating robotics, super smart artificial intelligence, and data science to automate the entire research journey. From mixing ingredients for new materials and testing their properties, to analyzing complex data, dLabs are handling it all. So what's the big deal? The core power lies in their ability to perform what's called high-throughput experimentation. Think of it like this. Researchers can now explore an incredibly wider range of material compositions and processing methods, way more than humans could ever manage on their own. This dramatically speeds up the hunt for novel materials with specific, desired properties. For instance, dLabs are busy autonomously creating thin film materials, super thin layers used in electronics, and evaluating them, a process that used to be incredibly slow due to data collection bottlenecks. Now, artificial intelligence and machine learning are the true MVPs here. They don't just tell the robots what to do, they intelligently guide the entire discovery process. These smart algorithms can sift through vast datasets, identify subtle patterns, predict how materials will behave, and even propose brand new experimental routes. This data-driven approach means research becomes more targeted, resources are used efficiently, and less time is wasted on trial and error. Picture this. AI platforms like Polybot are being used to produce high-conductivity, low-defect electronic polymer thin films. That's a fancy way of saying really good materials for advanced electronics, and they do this by intelligently navigating almost 1 million possible fabrication combinations. This isn't just some far-off dream. It's happening now. Top institutions and companies are heavily invested. The University of Tokyo has a dLab system that fully automates material synthesis and evaluation. Argonne National Laboratories' Polybot uses AI to explore materials on its own. Chemical giant BASF's Digital Material Profiling Lab automates formulation, application, and testing, making data accessible globally for collaborative research. Over in Spain, IMDEA Materials is setting up a robotics lab dedicated to discovering new polymer-based materials using AI and automation. The benefits go way beyond just speed and efficiency. dLabs also boost the reproducibility and reliability of experiments because they minimize human error and standardize all the steps. Plus, they make data management and sharing much easier, creating rich databases that the entire scientific community can tap into to push materials science forward. This collaborative spirit is crucial for tackling huge challenges in areas like developing sustainable materials, creating next-gen electronics, and improving healthcare. Imagine research colleagues from different corners of the world accessing and using the same data in real time. This fosters an incredibly dynamic and innovative research environment. Looking ahead, dLabs are expected to become even more sophisticated. We're talking deeper integration of cognitive systems, AI, that can not only execute experiments, but also design them from scratch. This ongoing evolution promises to completely revolutionize how new materials are discovered and developed, paving the way for breakthroughs we can only begin to imagine. So the next time you hear about a revolutionary new material, remember the tireless, intelligent work happening in these automated digital laboratories. They're building our future, one experiment at a time. Thanks for listening.